Welcome back. Today we're going to be talking about a rational function, a specific one, x squared over x minus 2, and discussing what can go wrong when you're looking for asymptotes. Woohoo, yay! So let's get into this. Okay, so we've got a rational function. We got a polynomial on top, a polynomial on the bottom. And in fact, it is factored, right? We've got x times x up top and x minus 2 on the bottom. So we know what all of our zeros are. And right off the bat, our domain, we got to watch out for x equals 2. So don't let x equals 2. And as soon as we know that, that's our vertical asymptote. Yay! Woohoo! Oh, you can't see the word asymptote. Sorry about that. There we go. Pardon me, Sharktopus. Okay, so now what about horizontal? What sort of range do we have? And do we have any horizontal asymptotes? It turns out this is a very complicated question, because it turns out that the range of this function is actually pretty hard to get to. It's going to be a lot easier to look at the range once we have a graph, believe it or not. So, having said that, you already know that if we don't know the range, then that's kind of how we've been basing our horizontal asymptotes. So what are we going to do to find the horizontal asymptotes? And the answer is that is a red herring. There are no horizontal asymptotes in this one. Dun, dun, dun! In fact, this one has something called a slant asymptote, or a slasymptote. No, it doesn't work. Sorry. Okay, so exactly what do? Well, short version that I've been telling, kind of the shortcut version, let me write shortcut version, is that as x gets really, really large, it looks like f starts to look like x squared over x, which is x. So we say, x minus 2 stops being interesting and it just starts to look like x. And that's interesting because that's not a number. That is that y approaches x. Now it turns out this shortcut version gives us a great bit of insight, but it's actually a little bit wrong. Not a lot wrong. Well, I mean, as far as math's concerned, if you're wrong, you're wrong, and there's no more wrong or less wrong, right? It's wrong. But you're actually really close. And so what is the long version? The long version of looking for asymptotes is you actually divide. Now, it turns out that this one's really easy to divide. I mean, this one is actually a problem. Pardon me. Okay, so first off, I would recommend skipping the choking. Go directly to the division. I know, it's all the cool kids want to do the choking first, but stick with not the do as I say, not as I do. So skip the choking. Give me a moment here. Sorry about that. Go right to the division. So this division you can do with long division, or let's use synthetic division, right? So I want to do x squared divided by x minus 2. Okay. I know I'm old school, so I'm going with the choking first. Pardon me. So in order to divide by x minus 2, I'm going to go ahead and set up 2 inside my synthetic division. And then x squared, I'll remind you, you actually have to do all of the terms. So it will be 1, 0, 0. 1 comes down, 1 times 2 is 2, 0 plus 2 is 2, 2 times 2 is 4, bring down the 4, and the results of this are, remember, you reduce by 1 degree, so I've got x plus 2 plus 4, which still has to be divided, right? Because that's the remainder right there. So, as x gets really, really large, what's going to happen? G is going to get really, really close to x plus 2. Not just x, but x plus 2. So the shortcut version, we were guessing x, and to actually use the division, we see that it's a little bit off from x. It's x plus 2. But this is very exciting because this is not a constant. This means that the asymptote is y equals x plus 2. This is called a slant asymptote, which you'll see in just a minute. Sorry, the choking, it's so compelling. So let's take a look at the graph, which I've already printed out. And again, Desmos unfortunately does not include all the x's and y's, so let me quickly go in and label everything, arrows, all that fun stuff. But let's take a look. What's happening here? Well, right here we see that we have the vertical asymptote, which is x equals 2. That's the asymptote we got. Oops, sorry, come back here. That's the vertical asymptote we could see directly from the domain. That was straight off the bat. We got that. And that one you cannot cross, and it is, you just, there you go. Vertical asymptote, yay. Now, the green, if you can see it that it's green, this is the graph of y equals x plus 2. And you can see why it's called a slant asymptote, because it is not horizontal, it happens at an angle, so it's at a slant. And you'll notice that the graph sits right here and right there. Now, how would we figure that part of it out? Well, if you went ahead and worked out a table of values, for example, if you tried out what happens when x is 0, 0 squared over -2 is 0. So we get this point right there at 0, 0. We could also check to see what happens at, for example, x equals 4. That would be 4 squared all over 4 minus 2. So that's 16 all over 2. So that's 8. Do we see that? And the answer is yes. I see that right here. There's that 0.48. And once we got these 2 points, you can kind of see that shape right there between the asymptotes. But you could, of course, always go ahead and plot a bunch of other points as well. Wow. That's very exciting. I don't know if you can hear it in the video, but something massive just flew overhead. Possibly a UFO. If I suddenly disappear, you'll know the UFOs needed help with their math homework. So, what are the lessons from this particular problem? Well, this particular problem gives us a couple lessons. One is sometimes the asymptote is slanted, not horizontal. Vertical asymptotes stay the same, so we've got a vertical asymptote. In this case, it turns out there are no horizontal asymptotes, and the only way we can really be sure about the asymptote, instead of using the shortcut version, which in this case is a little bit too wobbly, we use the long version. We do the actual work of division, and then we see, as x gets really large or really negative, This becomes a 0, and we're left with x plus 2. So if you want to be sure about your horizontal or slant asymptotes, always do the division. If you're okay with just getting the basic idea but maybe being a little bit off, you know, you can always just take a look at what the trend of the function itself. So that's it. Hopefully I will see you in the next video. We're going to be in a brand new chapter. Woo! So, and assuming that the aliens have not landed in my backyard and are not planning to take me off to go help them with their homework. However, if you would like help with your homework, please do not hesitate to ask. And there are always tutors in case I am still, you know, off on that alien ship. But otherwise, you know, go get a break, look at something green, know that I'm incredibly proud of you. Take care of yourselves. Be good to each other. Woohoo, and math on.